afternoon, everyone. My name is ADITYA BHAT. I am pursuing second year MTech at the National Institute of Engineering, Mysore. And my project title or conference title is Analysis of Roller Conveyor and SP Shuttle for Gantry Automation of Flywheel. And I have conducted this project at Felsomat India Private Limited, Bangalore. It is an industry. So first, through the abstract. So, automation is the application of mechatronics system to increase productivity by minimizing human intervention. So basically, my project is involving the gantry automations. So gantry system is one of the advanced level of material handling systems. So whatever work I have done, it is aimed at performing pneumatic analysis of material handling systems like roller conveyor and SPC shuttle. SPC shuttle means shuttle processing contractor, which is used to manually inspect a material after machining is done during gantry automation. And the work, this one is used this flywheel component for automation. The pressure versus displacement graph has been obtained by taking into consideration the force applied on piston, bore diameter, and stroke of double acting cylinder. Is supported by a number of rollers on which is conveyed manually, automatically, or by gravity, and it is used. So in our project, at input and output, a roller conveyor is used to move the flywheel and perform the gantry operations for loading and unloading of parts. Shuttle processing contractor, SPC shuttle, it is nothing but it is used to inspect the component after the machining is done, whether the component is as per the dimensions after the machining is done, like that. In the gantry workstation, where manual inspections are done after the part is being machined by CNC machine. So the component used in our project is flywheel. It is the heavy wheel attached to the rotation of the shaft so as to smooth out delivery of power, and it balance of engine, make rotation uniform. So this is the layout of gantry system used in our project. So it from right side we can see there is an input conveyor. It is nothing but a roller conveyor in which initially we manually load 7 parts. As we can see over here, there are 2 such rows where we can load 7 into 2, that is 14 parts. Then the gantry, that is the load, unloads the part from the conveyor and places it on CNC machine where facing operation occurs. Then the gantry unloads the part and keeps it on the 0 to 180 degree indexing station. This 0 to 180 degree indexing station is nothing but it is used to rotate the part by 180 degrees so that both sides of the flywheel gets machined. As we know, there are 2 sides for a flywheel. If one side of the flywheel gets machined, it should get machined on the other side also. So to rotate by 180 degree, 0 to 180 degree indexing station is used. Then there is a transfer shuttle where the part is transferred from 0 to 180 degree by the gantry loader, and the orientation station is there to make sure that the part is oriented properly as per the program or not. Once the loader unloads the part from the orientation station, it is moved on to the SPC shuttle, where it is checked manually whether the machining is done as per the dimensions or not. If it is okay, then it is carried on to a CNC thread cutting machine and gear pressing machine, where the 2 operations are done. Then again, there is one more we can see over here, SPC shuttle 2. After 2 machining operations, whether the part obtained is as per the dimensions or not, that is checked manually over here. Then there is a transfer shuttle in our project. There is 2. One, it is after CNC facing machine. Another one after this gear pressing machine and SPC shuttle. Then there is one more 0 to 180 degree indexing station where the part is oriented to its original position where it was kept on input conveyor. Then it moves on to ring gear heating machine where the gear pressing operations are done. And finally, the gantry unloads the parts and keeps it on the output conveyor, where manually we can remove the part after all the meshing operation occurs. This is the top view of our gantry system. And this is the view of the gantry system. There are two H loaders. H loaders means these loaders are in the shape of H. So it is called as H loaders. One loader is used to unload the part, and other is used to load the part onto the CNC machine and other subsequent stations. Then there is this is a 18-meter beam which is split by 3 meters each of 6 beams are used. Then there is a cable track chain, or we use something called as IGUS company chain, IGUS chain we call it as. Then belt version is used, where belt is used to move on the gantry system from input conveyor to output conveyor and doing the subsequent operations. So this is the system description which I told you now. Input roller conveyor is used to manually load the part. Manually it is loaded part and the gantry unloads the part. 0 to 180-degree indexing station is used to rotate the flywheel by 180 degrees to ensure that machining happens on both sides of the component. Transfer shuttle is used to move station towards orientation station and to check whether the orientation happens correct. Then there is output roller conveyor. It is used to load the component by the gantry and the removed after all the operations. H loader is the system consisting of two independent arms with position in parallel. So this methodology project had studied the project design. The floor plan and individual assembly design has been studied. Shows in the further slides, like double solenoid valves are used, then flow control valves are used. Then the different parameters has been collected by studying the cylinder description given and studying Festo manuals. The cylinders used in our project are basically Festo company cylinder. By studying those manuals, I came to know what are the bore, then stroke required, then other parameters. Analyzing the pneumatic circuit using Automation Studio. I have used the Automation Studio software to analyze the circuit, then draw the different circuits. Then I have extracted the graph of pressure versus displacement from a pneumatic circuit. There is an option called as XY plotter because pressure is one parameter and displacement is another parameter. So there are two axes and the plot has been obtained subsequently. So as I said, this is the first station in our project. It is the input roll conveyor. Of individualizer and stopper are used to move the part from this to end of the roller conveyor. And a Poka-yoke flap is used. Poka-yoke means fold proofing. Fold proofing is used to make sure that the components are not hitting it and there is no accident occurs between the part, and the end covers are used so that the part doesn't fall from the end of the conveyor, and this is powered by a induction motor basically. So this is the SPC shuttle I had mentioned. It consists of part locator, Poka-yoke flap, sensors stand. It is used to manually inspect the part. As we can see here, part locator, the gantry unloads the gantry loads the part on this part locator, and is powered by a pneumatic cylinder where it moves front towards the Poka-yoke flap and goes towards the end. And at the end, manual inspection is done whether to check the component is proper as per the dimensions or not after the CNC machining is done. This is the pneumatic analysis of input roller conveyor. You can see there is one input source over there. We normally provide 5 to 6 bar of pressure from the compressor. Compressor in the company is kept at the somewhere end corners, safety purpose. There is the FRL unit where filtering, regulating and lubricating of part is done. Then there is a 5x3 double solenoid valve where there are three positions. We can see there are one position is is used to move the cylinder in forward direction, another to move in reverse direction. This third position in the middle is used because in case of emergency purposes, like if the current goes on suddenly, the component should not hit the, or accident should not happen from the cylinder. So flow control valve is used to control the flow, as the name says, to maintain the flow of the cylinder at the rate. So similarly, there are two input roller conveyors I have mentioned. There are stopper cylinder and individualizer cylinder. In one roller conveyor, there is one individualizer and stopper. So for two roller conveyors, there are two stoppers and individualizers. So in the same sequence, the operations occur. This is the simulation I had taken, screenshot I had taken from Automation Studio, how the flow occurs towards all the four cylinder, and it happens in sequence. So this is the pressure displacement I had a graph I had obtained from XY plotter in Automation Studio. The standard air cylinder of bore 32 mm and stroke 60 mm is used for both individualizer and stopper units of input conveyor. The force applied on this cylinder is 80 newtons. From the pressure versus displacement graph, it is observed that displacement increases, pressure also increases, and as the applied pressure, we can see over here, the graph has gone up to 6 bar. So it is the 6 bar pressure. So this 6 bar is set in the FRL unit and the operation is done. So similarly for pneumatic analysis of space shuttle, there is one cylinder which is used where there is a source from compressor comes, then it goes on to the FRL unit. There is check valves and 5x3 mid-centered valve. Then the flow is controlled by flow control valve, and double acting cylinder moves either forward or reverse based on the 5x3 mid-cylinder valve. One position is to move forward and to another position is to move backward, as we can see three position of the cylinder, and one is for emergency purpose like current power loss and all. So this is the similar pressure versus displacement graph I adopted from my Automation Studio by considering the stroke, which are 25 mm. No, sorry, cylinder bore, which is 25 mm, and stroke is 630 mm of the cylinder. Then force applied is same as like input conveyor, it is 80 Newton. It is observed that as the displacement increases, pressure also increases. And we can see over here, the pressure goes up to 12 bar. So the initial pressure we had considered for setting is 12 bar. So conclusion, from the pneumatic analysis of input roller conveyor, it is observed that displacement increases, pressure also increases, and all the cylinders of individualizer and stops in sequence. And from the conclusion of shuttle station, it is observed that as the displacement increases, pressure also increases. Same type of survey over here, and the Poca flap fluctuates as part moves through it. These are the references. Thank you.
Thank you, sir. That was a wonderful presentation.